Japan has roughly 12% of its land available for farming. The American Midwest has more arable land in a single state than Japan has in its entire country. And yet Japanese rice paddies have been feeding large populations continuously for over 2,000 years on the same soil, in the same fields, without running out. American corn farming on the most fertile land in the world has lost roughly 1/3 of its topsoil in the past century. In 1909, a University of Wisconsin professor named Franklin King traveled to Japan, China, and Korea to understand how farmers in those countries had worked the same ground for 40 centuries without destroying it. He came back and wrote a book called Farmers of 40 Centuries. American agriculture largely ignored it. The soil science it described is now being rediscovered by researchers who are finding, again, what Japanese rice farmers never forgot. These are 5 things Japanese rice farmers knew about soil that American corn farming is still learning. They returned everything. After every harvest in a Japanese rice paddy, the farmer returned the rice straw to the field. Not most of it, all of it. Cut, turned under, allowed to decompose in the flooded paddy water over the winter months, feeding the soil's microbial community, rebuilding organic carbon, returning to the ground what the ground had spent growing the previous season. This practice, maintained continuously across thousands of years, is the reason Japanese paddy soils have accumulated levels of soil organic carbon that most American corn fields cannot approach. American corn farming moved in the opposite direction. Crop residue was removed, burned, or baled. Organic matter was replaced with synthetic fertilizer, nitrogen, phosphorus, and potassium applied to a chemistry problem rather than a biology one. What synthetic fertilizer cannot replace is the microbial community that turns organic matter into plant-available nutrition, builds soil structure, and creates the water retention that determines whether a drought year is a hard year or a catastrophic one. Japanese paddy soils, after 2,000 years of returning everything to the ground, have microbial communities of a depth and diversity that American soil scientists are now actively studying and documenting. The practice wasn't mysterious and it wasn't complicated. It was simply returning what you had taken. They managed water like a resource. A Japanese rice paddy is not simply a flooded field. It's a water management system with centuries of engineering intelligence built into every levee, every canal, every drainage gate. Water enters the paddy from forest and mountain streams, carrying dissolved nutrients from the surrounding landscape. It floods the field for the growing season, suppressing weeds, regulating soil temperature, and creating the anaerobic conditions that preserve organic carbon in the soil. Then it drains, precisely controlled, deliberately timed, allowing the soil to breathe before the next flood cycle. This alternate wetting and drying isn't an accident of landscape. It's a technique refined over 2 millennia to maximize what water does for soil rather than simply delivering it to a plant. American corn irrigation was designed differently. Pull water from the aquifer, apply it to the crop, drain the excess. The Ogallala Aquifer, which supplies water to much of the American Great Plains, is being drawn down at a rate that exceeds natural recharge by a factor that researchers now estimate will leave parts of it effectively unusable within the lifetimes of farmers currently working above it. Japanese paddy water management returns water to the system as deliberately as it takes it. American corn irrigation hasn't always worked with that same assumption. They farmed together. In Japan, rice paddy farming created a social structure called yui. It wasn't a government program, and it wasn't a cooperative in any formal sense. It was simply the reality that a rice paddy's water management connects every farm upstream to every farm downstream. You can't flood your paddy without affecting your neighbor's field, and you can't drain yours without changing the conditions in his. This interdependence wasn't a problem to be solved. It was a system to be managed, and Japanese farming communities managed it through centuries of established cooperation, shared labor at critical moments, and the kind of long-term relationship with neighbors that forms when the land makes isolation impossible. American corn farming moved toward independence as a virtue: bigger machines, bigger fields, single operator, efficiency on operations that once required community and cooperation to sustain. The isolation was productive in the short term. What it cost in the long term was harder to see. The knowledge that passes between farmers who work adjacent land, what the soil did this year, what the weather pattern suggested, where the drainage was changing. That knowledge stops moving when the neighbors stop talking. They kept the floor permanent. There's no soil erosion in a properly managed rice paddy. No groundwater depletion, no salinization, no replant failure. The paddy floor, built and maintained by generations of farmers, receives nutrients carried by water from the surrounding forests and hills. Salt is rinsed away by the same water before it can accumulate, and nitrogen is cycled through the paddy ecosystem rather than leaching into groundwater. Franklin King documented this in 1909 with the specific admiration of a soil scientist watching something work that his own country's agriculture was already beginning to undo. American corn farming, in the same century, lost an estimated 1/3 of its topsoil to erosion from tilling, rainfall, and runoff. In Iowa, some areas have lost more than half of the original topsoil depth that the land carried when it was first broken. A paddy floor built 2,000 years ago is still the paddy floor today. The Iowa topsoil that washed into the Mississippi River in the 20th century isn't coming back in any time frame that's useful to the farmers working above where it used to be. They read the soil, not just the season. Japanese rice farmers didn't manage their fields by calendar alone. They read the soil itself, its color, its smell, its response to flooding and drainage, the health of the microbial community working below the surface. Organic fertilizer applications were calibrated, not just to what the plant needed, but to what the soil's biology could process and deliver. The distinction matters. A plant fed with synthetic nitrogen grows as long as the chemistry is right. A soil fed with organic matter grows plants across generations, because the biology that processes that organic matter is itself a living system that improves with attention and degrades with neglect. Japanese soil scientists developed, in recent decades, a soil fertility index called SOFI, the system for evaluating soil, microbial activity, and organic carbon balance that formalizes what Japanese rice farmers had been reading intuitively for centuries before any index existed. American corn farming is now, increasingly, studying the same things: the soil microbiome, cover crops, reduced tillage, the relationship between organic carbon and drought resilience. The science is new. The knowledge isn't. Japan has no room to waste its soil. That constraint, applied across 2,000 years, produced something that looks, from the outside, like superior technique. From the inside, it was simply the answer to a question the land itself kept asking: what do you have to do today to still be farming this ground in 50 years? In 100? In 1,000? American corn farming is one of the most productive agricultural systems in the history of the world. It's also now working, in many places, on a depleted foundation that's thinner every decade. The Japanese rice farmer who returned his straw to the paddy last November wasn't doing something poetic. He was doing something that 2,000 years of farming had proven was simply the correct thing to do. The American farmer who is now cover cropping, reducing tillage, testing his soil for microbial health, is arriving by a different road at the same answer. New stories every week on Deep Furrow.